Assalamualaikum warahmatullahi wabarakatuh. My name is Firaz Fhansurie bin Musa, and this is my group project for MAT 263 Linear Algebra 1. My topic is application of linear algebra in electrical engineering. Introduction. Matrices can be described through a system of linear equations, more specifically, a two-dimensional vector with an input and output. With that, linear algebra is repeatedly used in electrical circuits, when using Kirchhoff's law to create equations, and solve using matrices and Gaussian elimination helps to simplify the solution. This is our problem. Use nodal analysis to find the voltage at each node of this circuit. Our objective for the study. We can use nodal analysis to write down a system of equations describing the circuit. We can then use Gaussian elimination to solve this system equation. Thus, our objectives are as follows. To use the required linear algebra method to my case study, the Gaussian elimination method. To calculate the voltage at each node of the circuit. And finally, and most important, to learn from the results. The methodology. Set up and solve a series of equations in which the unknowns are voltages and the main circuit nodes. The current in the different branches of the circuit are easily calculated from these nodal voltages. The steps in the node analysis method are count the number of principal nodes or junctions in the circuits. In this case, we have 3. We choose one node and assign it to 0. Write down the Kirchhoff's current law for each node. Call V1 the voltage node at node 1, V3 the voltage at node 3, and V2 the voltage at node 2, which we assigned as 0. Express the current in each branch in terms of the nodal voltages at each end of the branch using Ohm's law. I equals V over R. Node equations. This is the first node equation, and then we transform it into a collecting terms, which we can simplify it into an augmented matrix, which is 1 over 3, 1 over 10, 20 for row 1. Row 2 is negative 1 over 10, 1 over 4, and 5. The Gaussian elimination method. We write the system in matrix form and solve it by Gaussian elimination. We assume that row R1 equals to row 1 and R2 equals to row 2. So here is our elimination method. This is our first matrix. The first step is to divide the row 1 by 1 over 3. Divide each number of row 1 by 1 over 3, and then we get 1, negative 3 over 10, 60. And then we multiply row 1 by 1 over 10 and add it to row 2. With that, we get 0, 11 over 50, and 11. After that, we repeat step 1 again, step 2 again. R2, divide the R2 by 11 over 50. Then we get 0, 1, 50. And repeat step 3 again, which is multiply R2 by 3 over 10 and then add it to row 1. So the final answer will get 1075, 0150. Thus, the solution is complete. The result of the calculation is V1 equals to 75 volts and V3 equals to 50 volts. In the Gaussian elimination method, elementary row operations or EROs are applied in specific orders to transform an augmented matrix into triangle echelon form as efficiently as possible. That's all for my presentation for today. Thank you so much, miss.